Hi everyone, in today's lesson we're going to talk more about motion of a line. We'll call this motion of a line day 2. Our main focus today will be the difference between something called displacement and distance. So displacement is the length of the shortest path from start to finish. So here's a visual representation. If you look, the particle starts here where it is in green and ends there in red. So from start to finish. So this distance from here to here will be the particle's displacement, where I started, where I finished, and that straight line distance. How we can calculate that is by taking the S of B value and subtracting S of A, where A and B is the closed interval. Now, I'll explain what this means when I do an example, but at least you have this so you could look back at it. All right, so now distance. Distance is the length that the particle travels in total. So if you look at this example, the particle starts here, travels all the way around, and then finishes. So this orange piece right here is all of the distance that the particle traveled. So that distance is actually going to be greater, in this case, than the displacement. And here are the steps of how to calculate the distance. I'm not necessarily going to read through them right now. We're going to use them in an example in a little bit. All right, let's try an example. So example here says, a particle moves along a horizontal line according to this function. When t is time and it's measured in seconds, and s of t is measured in meters. So find the displacement of the particle during the first 5 seconds. So what that means is from time is 0 to time is 5. Because time can never be negative, so the first 5 seconds would mean 0 to 5. So if I want to find the displacement, what we want to do is calculate using the formula S of B minus S of A, where A and B are the endpoints of the interval. So 0 would be A and 5 would be B. So I want to calculate S of 5 minus S of A. Excuse me, not A, S of 0. So S is your standard position function, which is this. So you can honestly just put this into the y equals and look at the values or the table of values when x is 5 and x is 0. Or you could plug in, and just solve. So S of 5 would be 2 times 5 to the third minus 15 times 5 squared plus 24 times 5 plus 8. And S of 0 would be 2 times 0 to the third minus 15 times 0 squared plus 24 times 0 plus 8. So whichever method you're going to do, whether you're going to plug it into the y equals or you're going to substitute here, take a minute, pause the video, try it, and then hit resume when you're ready for the answer. Okay, so for S of 5, I got 3. And for S of 0, I got 8. So when you're going to do 3 minus 8, you're going to get negative 5. Now, some of you might be wondering, what does a negative 5 in the displacement mean? Well, it means that we landed left of where we started. So you could say the particle ended 5 units to the left of where it started. Now, if your displacement was positive, the particle would have ended 5 units to the right of where it started. So if you want to write that down, that might not be a bad idea. And I'm going to show you and prove that this negative 5 means left when we draw the picture. So part B says, find the total distance now traveled by the particle over the first 5 seconds. So we need to find the distance that this thing traveled. So in order to do that, we have to do something first. We need to find where the particle is moving left and where the particle is moving right. So we first need to do where v of t is equal to 0. So we need to take the derivative of s of t. So if you want, I can write s of t one more time. So s of t is 2t to the third minus 15t squared plus 24t plus 8. So I want to take the derivative of this function and set it equal to 0. So remember, the derivative of the standard position is the velocity. So if you take the derivative, it's 6t squared minus 30t plus 24. So we're going to go ahead, put that velocity function, and set it equal to 0. So to solve, we're going to factor. I believe I could divide all three pieces by 6. So I'll be left with t squared minus 5t plus 4. I can factor this inside by am, or add multiply. And that gives me -1 and -4. And when I do my t-chart, 6 equals 0 makes no sense. Time equals 1, and time equals 4. So what you just found is where the particle changes direction. Remember, that's what v of t equals 0 means. So where it changes direction. Now, to find the total distance traveled, we don't necessarily need to find exactly where the particle is moving right or left at this point. But what we're going to do now is, since we know the particle is changing direction here and here, I need to figure out where it is on the standard position or on the horizontal line. So step 2 is going to be to make a chart. And you're going to make this chart with the values of the interval. So for the first 5 seconds, your chart is actually going to be t, and then your s of t values. And with this chart, we're going to do 0 and 5. Now I put the 5 down there because there are two values where it changes direction in between, so 1 and 4. So we want to find where the particle is on the horizontal line using our s of t function, right? This gives us our standard position, or where the particle is at any given moment. So take a minute, plug your s of t function, this one, right, into your calculator, into your y equals, and find the y values for these corresponding x values. So again, just your s of t function, so this one. So take a minute, do that, pause it, and hit resume until you're ready for the answer. Okay, at 0, I have 8. At 1, I have 19. At 4, I have -8. And at 5, I have 3. So what you just found, these are the values where the particle is on the horizontal line. So where particle is on horizontal line. So the only way we can find a distance is if we draw a picture. So the third step for this is going to be draw a picture and calculate the distance. So remember, we're on a horizontal line. So if it helps, you can draw a number line below to kind of gauge where you're going. So at time equals 0 seconds, my particle is at 8. So we can put 0 right in the middle, and we can estimate where 8 would be. So let's put 8 here, and let's put a dot right above it. So this is labeled time equals 0. So at time equals 0, I'm at 8. At time equals 1, I'm at 19. So let's just say 19 is here. And let's label this time equals 1. So I went from here to here. Now at time equals 4, I'm at -8. So I need a new spot on my graph. Let's just say here. So I'm going to travel all the way this way. And this will be time equals 4. And then time equals 5 looks like I'm at 3. So I'm going to go back over. I'm going to end here at time equals 3. Excuse me, 5. So if we want to calculate the distance, all we have to do is add up all of the pieces. So from here to here, from 8 to 19, I've traveled 11. All I have to do is subtract those values, right? Then I went left all the way this way from 19 to -8. So from 19 to 0, I know is 19. 19 to 8, add 8 more, we're at 27. So from here to here is 27 units. And then last but not least, I'm going right again, but from -8 to 3. So -8 to 0 is 8. Add 3 more, I've got 11. So from here to here, I've traveled 11. So my total distance is going to be 11 plus 27 plus 11 more. So that is going to be 49 units for my distance. Now, just to talk about the displacement for a second. So look where the particle started and look where the particle ended, right? If you want to label, this is the start, S for start. This is the E, or ending value. Maybe I'll write it out, right? Here's your start, here's your end. So if I started at 8 and ended at 3, didn't I end 5 units to the left of where I started from, right? 8 minus 3 is 5. And that was our displacement in the first part, right? -5 means I started or ended 5 units to the left of where I started from. All right, that's it for today on distance and displacement. If you have any questions, now is a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.